Uh, this is polarized state of axon membrane when outside is electropositive as compared to inside, or you can say inside of the membrane is electronegative as compared to outside. The potential difference of inside is minus 70 millivolt. At potential difference minus 70 millivolt, when we apply a threshold stimulus, potassium permeability stops. Now sodium starts moving inside. Due to movement of sodium ions from outside to inside, it leads to accumulation of positively charged ions inside. It starts depolarization of axon membrane. Due to depolarization of axon membrane, potential difference, which was initially minus 70 millivolt, is increased. It goes up to minus 55 millivolt. At 55 millivolt difference, which I have marked it as firing level, at this level voltage gated sodium channels opens and it causes the depolarization of entire axon membrane. In this diagram you can see initially sodium ions enters through ion channels. It causes depolarization of the axon membrane. When minus 55 millivolt potential difference is achieved, this voltage gated sodium channel opens. Now sodium enters into exoplasm not through ion channels, it enters through the voltage gated sodium channel. The voltage gated channel which was previously closed during resting membrane potential stage, now it opens and it leads to sudden influx of large amount of sodium ions inside. It causes depolarization of entire axon membrane. At 30 millivolt potential difference, which is referred to as spike potential, voltage gated sodium channel is closed and voltage gated potassium channel opens. Due to opening of voltage gated potassium channel, it causes efflux of potassium ions from inside to outside. It again, as a result, it leads to accumulation of positively charged ions outside. This is called repolarization. In this diagram you can see potassium ions efflux occurs through voltage gated channel. Due to efflux of positively charged ions outside, again normal resting membrane potential is achieved. Now we have to discuss how does impulse transmission occurs at synapse. Synapse is a space between two neurons. This is one neuron, this is other neuron. This membrane can be called as presynaptic membrane. This membrane can be called as the postsynaptic membrane, which is a part of dendrite. This is a part of axon terminal. Axon terminal contains certain synaptic vesicle, and synaptic vesicle is loaded with a neurotransmitter. There are many neurotransmitters, but the most important one is acetylcholine. ACH is a short form of acetylcholine, which is present in synaptic vesicle. Axon also contains a voltage gated channel called calcium channel. This space is called synapse, which is filled with synaptic fluid. How does transmission of impulse occurs at synapse is explained by a mechanism called synaptic transmission mechanism or chemical transmission mechanism, because acetylcholine is a chemical involved in such transmission. According to this mechanism, when an impulse arrives at axon, voltage gated calcium channel opens. Previously it was closed. So influx of calcium ion occurs from outside to inside. What is role of calcium ions in impulse transmission mechanism? Calcium causes the translocation of synaptic vesicle towards the presynaptic membrane. Now the membrane of synaptic vesicle and presynaptic membrane gets fused and the content is released outside. The content is called acetylcholine. The receptor of acetylcholine is present on postsynaptic membrane. These are receptors of acetylcholine. So acetylcholine diffuses in synaptic fluid and ultimately gets attached to its specific receptor. Acetylcholine is a ligand. It opens the sodium channel present on postsynaptic membrane. So when ligand gated sodium channel opens, it leads to influx of sodium ion in large amount, and when sodium enters from outside to inside, again sodium, because sodium is a positively charged ion, it causes accumulation of positively charged ions inside, so that outside of the membrane becomes electronegative. In this way, a new impulse is generated at postsynaptic membrane, and once the impulse is generated, again it is conducted according to law of conductivity. Now see, acetylcholine which have released from axon again enters into axon. How? This is recycling. How does recycling of acetylcholine occurs? Acetylcholine consists of acetic acid and choline. There is a enzyme present on dendrites called acetylcholine esterase enzyme. When this enzyme acts on acetylcholine, it is broken into its constituent. Constituent are acetic acid and choline. Now when such constituent enters into axon membrane, axon contains another enzyme, acetylcholine transferase enzyme. It leads to regeneration of acetylcholine molecule. This is how the impulse cannot transmit in opposite direction, because acetylcholine is present in axon and their receptors are present on postsynaptic membrane. If acetylcholine are present here and receptors are present at presynaptic membrane, then impulse can also proceed in that direction, but transmission of impulse is always unidirectional because of this fact. Axon contains acetylcholine, their receptors are present on other neuron. Delay, synaptic delay. Synaptic delay, it is time taken by an impulse to cross the synapse. Impulse is generated here. Now the impulse has to transmit into the next neuron. The time taken is called synaptic delay. One more definition you should learn is refractive period. The refractive period is the period during which a neuron cannot perceive a new stimulus. This period is about 1 millisecond. Yes.